Welcome back to Learning with me here at MPB. My name is Ms. Killen, and we're going to jump into some more Algebra 1, our Unit 5, which is our linear equations and functions. So today we're doing Lesson 2, which is our rate of change of linear equations. We're looking at ID 7, LE 5, and NQ1. We are going to be able to say that I can interpret rate of change from a linear graph in a real world context, because a lot of our problems have that real world scenario that we have to look at. So let's go and see. All right, so the first one we have, remember, we always read our passage. Hank makes 12 paper airplanes every day. Michelle makes 6 paper airplanes every day. Let's graph both situations. Make sure to use the same scale on both of your graphs. So let's go ahead and do this. So the first thing is I'm going to graph Michelle's over here on the left. Now it says that she makes 6 paper airplanes every day. So for her first day, she has 6 airplanes. Her second day, she would have 12 airplanes. Her third day, she would have 18 airplanes. And her fourth day, she would have 24 airplanes. And then I run out of room, but that's okay. Now let's go to Hank. Hank's is going to look just a little bit different. So let's look at Hank. Hank is on his first day. He has 12 airplanes. On his second day, he has 24 airplanes. And then on his third day, he would have had 36 airplanes. So we can see the different points on my first days of both people, my second days of both people. So we could say that they are changing from day to day differently. So for Hank, I'm adding 12 each day, and for Michelle, I'm adding 6 each day. That's what we call our rate of change in that context. So here it says, Scott's factory sells wireless earphones for $25 each. Joey's factory can sell the same earphones for $35. Graph each factory's money per product. So I'm going to work up here on my board. You work on your notes page, and as soon as we both get done, let's see what we've got. Okay, so let's see what we've got. I have, for Joey and for Scott, I have plotted different terms. So for Scott, I have the red dots, and for for Scott, I have the black dots, and for Joey, I have the red dots. Does your graph look something similar to mine? So I could say for Scott, I have $25 each headphone, and then for Joey, I can say that I have $35 per headphone. Now, one thing we need to remember, we're going to see that 3-letter word a lot in these word problems as we go through Algebra 1. This word per, it means I am going to multiply something, or I am doing something per something, or a number for each individual. So that per is going to be very important as we go through these word problems. So let's look at the next one. It says in all of these graphs, we could see that the rate of change, or our slope, we saw what we did to go from one point to the next, which was our rate of change. Now, we've learned that our slope is rise over run. We've learned that our rise means what we're doing for our y values, and our run is what we're doing for our x values. So what I do to go up from one point to the next. So if I started right here, for me to go to my next point, I would have to go up so many and over so many, up so many and over so many. So if I had, this would be the graph that I'm looking at. So that's what is showing. That's what is showing for us to go from one point to the next when looking at these graphs. Good job. Let's look at Justin's miles that he drove today. What could we say his rate of change is And what does this rate of change tell us about the graph and the situation? Well, first of all, I always read my graph to get all the possible information that I can get from it. On my y-axis is my miles, and on my x-axis is my hours. I've learned that my x-axis is my independent variable, meaning no matter what, it's going to be the next hour and the next hour and the next hour. And I've learned on my y-axis is my dependent. Depending on what happens with my x depends on what my y is. So I could look at 0 hours, he's done 0 miles. That first hour, he has 50 miles. That second hour, he has 100. That third hour, 150, and so on and so on. So what could I say that his rate of change is? My rate of change, remember, rise over run. So I go up 50 miles and go over 1 hour. I go up 50 miles and go over 1 hour. I go up 50 miles, over, up 50 miles. So I could say that my rate of change is 50 over 1. So what does this rate of change tell us about this graph? That every hour, he's driving 50 miles. He's probably going 50 miles per hour. There's that word again, per. 50 miles per hour. You're telling me, Ms. Killen, we can figure out how fast we go? Yes, we can. Yes, we can. Let's look at some more. First, we got to read our passage. Drew gets an allowance each 14 days from his aunt. At the beginning of the 2-week period, he gets $50. He likes to download 2 songs, $3, from Songify every day to build his song collection. The graph shows how much money he spends on songs between February 2nd and the 11th. All right, so let's look at this. When it's 0 days, he's got 0 songs. For that first day, he's spent $3. On that second day, he's spent $6, and so forth and so on. So what could I say about this passage? At this rate, how much money will Drew have spent on that 9th day? Well, now, Ms. Killen, you didn't graph all 9 days. That's true, but we can still figure this out. I know that each 2 songs that he buys cost me $3. Okay, so that means every day he spends $3. So in 9 days, how much would he have spent? On that 9th day, he will have spent $27. Now, it didn't tell me all of that in my passage. I had to read the information from my graph. You always want to make sure that you're reading your passages and you're looking at your graph to make sure that you can pull all that information out. Now, it's time for you to show some mastery. What I want you to do is read your passage, work your problem. If you need to, talk to that table partner, see what they say, and when you're done, come back to me.
3.
All right, let's see what we've got. The amount of a medicine in a patient's bloodstream is shown by the function A of H equals 600 times 75/100 to the H, where H is the number of hours that passes since the medication or the medicine has been given. What does 0.75 represent in this function? Think in terms of 1 being a whole. So if I'm every hour taking in account 0.75, or if I'm thinking of a whole, 75%, I would say that this number shows that 25% of the medicine leaves the bloodstream. Now, this might be something or a question that you would see in that biology. And we also know that they bring those biology concepts into our math. So it's good to be able to read those functions and understand what all the components mean in that context. Okay, so I don't want us to forget, our rate of change is the same as slope. We're still using that rise over run as our slope. We want to make sure that each time that we're using a graph, we are always labeling our axis. And when you're working with decimals in a percentage way, you always want to make sure that 1 equals that whole part. I'm so glad that you came to work with us here at MPB. I'm so glad that you're learning with us and we're growing in this Algebra 1. Thank you for coming. My name is Miss Kimberly. Have a good day.